Hey everybody, this is Larry. This is me going with Q3 of the bi-weekly contest 117, number of strings which can be rearranged to contain substring. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. This one was pretty hard, pretty tricky, pretty easy to get wrong. And I tried a number of different ways. You could watch me solve it live during the virtual contest. I tried a lot of different ways of counting it, and if you are getting the wrong answer, there's there are only two things, right? One is you're undercounting, meaning you're not counting possible subsequences or substrings or strings. And then the other thing is, overcounting, meaning you count too much. And in my case, I did a little bit of both. There are a couple of things you can do, but remember the most important thing is just thinking about trick cases. For example, for me, I think I did it in three different ways. Two of them were incorrect. How did I do it? Well, one of the ways that I did it was that I just thought, okay, well, we have 4 characters that are fixed because when it comes down to it, it's just 12 times, which is 4 factorial over 2 factorial over 1 factorial over 1 factorial. Basically this sequence, and it's going to be 12 times this in some permutation, right? And then after that, it's just realizing that it has step 1L, 2 E's, and 1 T, right? And then here, the idea is, my initial idea was that, okay, there are n minus 4 other things because 4 of these things are fixed. So then I can just do 26 to the n minus 4, right? 1 for each character, and then for each of the 4 characters, put it in one of the buckets in between them, right? Because basically you could think about these things as dividers, and then now you have this classic star and banner pattern over what it's called, right? Star and stripes, is it? Or bars and stars and bars. Right, so that's basically the idea. Of course, that doesn't quite work because the dividers it overcounts, right? Because, for example, this could be a yi, and if this is a yi, that means that you don't need 4 different things in there, right? Something like that, basically, like you cannot have LE, or this would be good enough, or maybe it undercounts. Oh no, definitely overcounts, because now we have more yi's than necessary and you're just overcounting some certain cases. And the very basic example is that if you have, 1 n is equal to 5, you have like right? Well, you're going to count something multiple times, because if you say, like, this as a word, then now it's the same as counting and yi on the other side, right? These are the same words. We counted it multiple times, right? So that's overcounting. What was the other way that I did it? There was another way that I did it incorrectly. You could watch the live portion. I think I go over it because I was like, oh wait, this doesn't work because of this other reason. But the tricky part is to kind of handle all of these. And the thing that I noticed during the contest is that only 3 characters, right? L, E, and T, which is good for the principle of inclusion-exclusion, right? Sometimes people abbreviate as pi for some reason. I mean, I get it, but I'm not. But yeah, it's inclusion-exclusion principle. And Google that up. But basically, the idea here is basically you have a pie chart. So let me bring up really quickly. The short answer is that, okay, now you have a pie chart, not pie chart. I say pie chart. I mean a Venn diagram, right? And then now basically you have to add in, for example, how do you figure out the area? The area, well, you have to add in all the 3 circles, right? Obviously. But then now, as you notice, we overcount overlapping circles, right? So now we have to subtract these because they're the overlaps of the things. And then here we notice that we overcount the subtraction as well. So that, because as you can see, so then now we have to add this back in, right? Because now, another way of saying is that the red piece, well, the red piece is good because it only appears in one thing. The green ones we in two things, so you have to subtract them because you counted it twice, because you counted it in the red piece and then the twice, right? And then the blue piece you have to add it back in because you double subtracted it from the green pieces in the section. So that's basically the principle of inclusion exclusion, and because of this, that's how I would solve it. The code here, I kind of wrote it in a way such that is from my understanding. You could definitely run this a little bit cleaner. For example, you could have just like, right? But this, I think this is good for reading. At least like if you want to go through my thought process and thinking about it, right? The total is going to be, or the total number of all possible strings is 26 to the n. Hopefully I don't have to explain this one. And then missing zeros or 0 L's and 0 T's, that's going to be 25 because you can use an L, you can use a T, and you can use any E's. One E is this thing. Basically it's the same idea. You have all alphabets 25 to the n minus 1, and then E in one of the 26 different locations, right? Or in any spaces in between all the characters. And then you could see me like literally enumerating it all out, so I hope I don't have to explain it too much. But yeah, if you have two of these, remember you have to well, I did it in a weird way because I did it from total, so you're trying to remove, so you have to total, you subtract all the one that appears once, and then you add in all the ones that appears twice, which is all these things, right, in two chunks, and then lastly all the things that appear in three things, you have to add it back in. Well, you have to subtract it back in my case. And then remembering to mod in a lot of places. And that's pretty much it. Very brute force, very low level, very mathy. I mean, yeah, obviously you could have written this in a much whatever way, but yeah, this is how it like you could win for loops and multiplications. Like for example, obviously we've done this 3 times, and and you can write this in a little bit of a for loop if you like. But end of the day, this is the thought process. This is the code, and yeah, and everything is going to be done in, I guess, linear time, depending on how you want to say it. Linear because, well, yeah, linear time, because POW will do repeat doubling, which is log of this n, which is linear because n has log n number of bits, and this takes log n time, so this is linear, right? And the same principle for all of them, so this is linear time, and space is also going to be the same for that reason, or one of you want to count it as mod, I don't know, right? But yeah, that's pretty much it. That's all I have for this one. Let me know what you think. And yeah, if you want to read up more on the inclusion exclusion principle, definitely Google that. And that's it. Yeah, I don't know if this would come up in an interview because it's a little bit too hard. Not even hard, it's just too mathy. But yeah, that's all I have. You could watch me solve it live, including the couple of miss attempts. Now, remember you could fast forward, so don't feel like you have to watch everything. You have to, I don't know. I have to come back to this one. I think I'm wasting too much time on the Q2, and I still don't know how. But okay, what is this math today? Number string like rearranged contains substring. Okay, and the string is s if it contains only lowercase to the n. It is possibly rearranging characters as such that new string. Okay. Okay, mod. And then it's just So it's just any strings that have one L, two E's, and a T, right? So less than 4, obviously no good. We can also do what's it? Times it by 4 factorial with 2 factorial. What is that? 12. I guess that's what it. So times it by 12, maybe. Okay, so then now we have these strings, and is it just 26 times whatever? Let's see, right? What is 26 to the 5th? Or to the 6th? Okay, fine. Because all the other characters don't matter, right? Is that it? Nope. Maybe all the characters do matter. What is 5? Or at least not in the way that I'm doing it. Why does it matter? So, oh, wait. Oh, because there's an ordering component. Right, so it's not just this times an A or add an A. There's an A in all these places, right? So then that means it's this times another, and we can actually, I want to know real quick whether my number is big. It should be, if my view is right, then my number should be smaller than this number. Yep. Okay, that's good. At least it's consistent. And then now, if we add in each it's going to be this. No, is it? So it's going to be 26, but then we can add it in each of the things. Okay, fine. I'll do it this way. Right. Equals 12. And then now we want for each character, so it's going to be times 12, or times 26, times the previous number of character, right? So I did my for loop in a weird way, but fine. And one, no, it's just plus 1 because that's the number of gaps that you put it in, right? Is that true? Because then now we're double counting some stuff, like if we have AA, then we add them in different directions, right? And that's double counting it, right? I mean, I know that we're double counting it. Let's see if double counting it gives us an over counting answer, right? This number should be bigger. Oh, nope. Yeah, this number should be bigger than that number because we're double counting some stuff with insert. Maybe the other way to think about it is, okay, we have 26 characters, 26 to the n minus 4, and then now we put in the 4 characters, right? Maybe that's a better way of doing it. Okay, so you have power of 26 and minus 4. Remember to mod, made that mistake before, right? So we have extra characters as you go to this, and then now we have to put in the 4 characters, right? which is, so now you have length minus 4. So the number of buckets is n minus 3. And it's n minus 3, and then you can choose the buckets. So then it's n minus 3. That's the number of buckets. You have 4 characters. And that's if they're not distinct. So now you have to add the distinctness. So that you have to times it by 12, right? Just want it real quick. At least get this one right. Okay. I think this mod is actually kind of. I want to see if the 10 matches the big number without the thing. Okay, the 12 is right, but this one's not so good, right? Is this wrong? Why are you wrong? Why are you wrong? Because we're double counting still? Is that true? Yeah, because we're double counting because we're putting in stuff. We're putting in things in a way such that we're using them as but then now we take out LENT, but then that's just like super weird and hard to do. I have to think. Wow, man, today is like a math. What is this? Am I interviewing for a math thing? Well, you skip Q2. How am I doing on time? Let's see. Wow, people finish up. Well, I mean, if it's some people are good at math, but this is not a great result. Q2, people got Q2. A lot of people got. Seems like, so I really should be able to do this. I don't know why I'm so stuck. But let's see if I can finish this first. Because I cannot treat them as different. That's why I'm double counting, right? Okay, so that we're trying to do. How about the opposite case, the impossible case? Can we choose the number of words that does not contain words that contain? So okay, 26 to the end, that's easy. Okay, and then now number of words that contains. What is the opposite? The opposite is all the words that does not contain it. And I'm just struggling today. So what does the opposite mean? That does not contain it, right? So that means that you're restricted to either one L, 2 E's, or 1 T, or some combination of them. And we could do like inclusion exclusion for it, I guess. Maybe that's the way to go. All right. 0 L's and 0 T's are going to be the same, but what is 0 L's, right? So that means that. Okay, let's see. Okay, total is equal to power 26 to n mod 0 else. 0 else is going to be basically power of 25 and mod, type it correctly. And also 0, was it t? Right, so this is twice, right? Missing L. Or no L's, whatever. Missing T, right? And then we have to use missing Y is a little bit tricky, right? Well, missing Y is fine, but it's one or fewer, right? So missing Y is also power of 25 and mod. And then one Y is equal, one Y is equal to power of 25. No, is it? It's going to be, if you only have one Y, what is it? It's 25 n minus 1, and then times n for the number of places you can put it. Right? So 1 Y, yeah, okay. I think that's right. I know this isn't right, by the way. I just want to get a sense of the numbers. Okay, I mean, you have to mod this, but that's fine because of this thing. Maybe maybe I could do it without mod. Okay, let's do. I just want to see if the 10 answer could be good. Am I already subtracting too much? Okay, let's do 4, right? 4, 26 to the 4th. I mean, yeah, I guess we're subtracting too much, but this is a lot for 4. Let's add in for 4, 3, 25 to the 4th. I mean, I know I have to do inclusion, exclusion, but this seems pretty big. Is this the right path? All right, well, for example, if this is 4, then it's just 26 to the 4th minus no L's. So 20. I mean, this seems right. So for the missing Y, I mean, this is definitely right. 1 Y is going to be 3 times yeah, it's gonna be okay, yeah, this should be right. And then now we have to add in the, so okay, this is gonna be the painful part, right? So missing L and missing T. L's plus 0 T's. So that means that things that are missing in both, so that means it's 24 times 4 and mod, right? 0 L's plus 0 E's. I mean, I know that I could write this like I know that these are repetitive, but I need to write them out. I feel like if I don't know, just hard. I mean, maybe we'll simplify it later, but for now, okay. And then the other, right? 0 L's plus 0 T's, oh, so plus 1 E's, right? Yeah. So basically with 1 Y, this is the hard case, right? Let's see something real quick. No. Let's say we add back. Does that look okay? That is ridiculous. Okay, fine. But this is why you have increased. Okay, and then now this part is okay. So you have 1 year but no L. So you have 25. Oh yeah, okay. That should be okay. So then now it's just 24 n minus 1 mod times n, right? Same thing for the t. Right? Yeah, my notation is definitely very typo friendly. And then now we have to resubtract some stuff. That is ridiculous, the numbers, but okay, fine. Which is so and 1 year, right? So that means it's going to be oh, 1 year, but this is subtract. All right, that's ridiculous that this works. This formula looks ridiculous every step of the way. We match this, so okay. This is ridiculous. I don't know why inclusion and exclusion is in my head, but all right, let's give it submit. I cannot do Q2. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest and problem. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.